Okay, hello guys. I'm starting forgetting you, and as usual, I'm Ejide Sanzmana. And as you have seen last time, we have talked about the mathematics for level 4 in Tvet, Rwanda, and we have talked about the first topic, where the first topic is about the apply fundamental for differentiation. So for any kind of review, yes, we have talked about the differentiation or derivative, and you have seen some operator of differentiation where you can just take your numerical function and then you have d over dx of your a given function, and you have seen that this function can be realized in terms of a given unknown variable, and also you can just have dy over dx in term where this y is the same as of fx, and you can just have the y days, or also you can just have the fx days. Then for this any kind of revision, we have seen that you can just make the differentiation by using difference method, where the first one we have seen that you can just make the derivative by using the method of definition, where for this case the derivative by using definition, we have seen that it is the limit of h tend to 0 of fx plus h minus fx over h. So for today we are going to continue with the second method, which is the derivative by using properties. Properties. So in order to make the derivative by using properties, we can just have the main difference properties here. So for today, we are just going to talk about with at least 5 properties. For the first property here, you can just make the derivative if you have a given constant. For example, if we have your constant, how we can just derive this constant. So for the second property, we'll talk about with the derivative of a given linear equation. For example, for the linear equation is when you have your unknown variable, which is have the power which is equal to 1. So for the third property, we'll talk about the derivative with respect to a given polynomial function. You can just have the polynomial function if you have your function which have a given n, where this n must be greater than 1. So, and also the fourth property, you can just talk about with the derivative of, or at least if you have two functions, for example, if you have fx and the gx, so how can we just make the derivative? If you have, for instance, the addition or subtraction, and then also we can just talk about with this by referring to the multiplication and the division or quotient. So after this one, we will talk about later with the derivative of rational function and also the derivative of some trigonometric function. So let us come up for the first property. Then for the first property, as I have told you, is when you have just a given constant. For example, if we have d over dx of a given constant here, for example, if we have a given constant like 4, like 7, like 100, and then it means that here you have a given number which is constant. So in order to make the derivative of this constant, for example, if we have d over dx, where our x here will be taken as a non-variable, and by referring to the constant, for example, if we have 4, in order to make the derivative of the constant here, the answer will be equal to 0 directly. So this is the first property. If we are just making the derivative of a given constant, the answer will be equal to 0. So then for the first property here is about if you have the derivative of a given function with respect to x, and then your function will be taken as linear equation, which is have the power which is equal to 1. It means that here it will be the same as for having this power which is equal to 1, and then you have to multiply here as a coefficient, and then you can just have your x, and and then you have to take your power which is equal to 1, -1. This -1 will be taken as a formula, and then you remain 1 times the x power 0. And you know, this x power 0 will be equal to 1. So we have 1 times 1, and then the answer here is equal to 1. So it means that if we have make the derivative of our x, the answer will be equal to 1. Then the third property here, we have a given polynomial function of the derivative of this function with respect to x if we have x power n. So it means that if we have this x power n, our n here, as I have told you, must be greater than 1. For example, you have the derivative of d over dx of x power 7, for instance. Here, you see our 7 here will be considered as n, and our 7 will be greater than 1, of course. And here, what you have to do, we have to take that power as 7, and you can just multiply as a coefficient, and then you have to take our x power 7, where this power minus 1. So for this case, it means that if I have this function which is looking like this one, you can just take this x power n -1. This is how we can just have our n times x power n minus 1 as a formula. This one will be taken as d over dx of x power n. So let us come up for our example. If we have d over dx of x power 7, so it will be easy. We can just take this 7 as a coefficient, and then times the 7 -1, where this 7 must be taken as n. So the answer will be equal to 7x power 6. So the fourth one property here, we can just talk about here. We can just consider the two functions. For example, if we have fx, which will be equal to x plus 1, and gx, which will be equal to, for example, x squared plus 3. You see, we have the two functions which are different, where the first one is fx and the second one is gx. So if we are asked to find the derivative of dx of fx plus or negative gx. So how can we do this one? It will be easy. So we can just make the derivative of the first function. For example, this is fx plus or negative the second derivative, the derivative of the second function, which is equal to gx derivative. So it will be the same. For example, you see here, and we have our function fx, which is equal to x plus 1. And then you have the function gx, which is equal to x squared plus 3. So we are asked to find d over dx of fx plus gx, for instance. It means that it will be easy if we find the fx, and then the answer we get here, you can just plus the derivative of the second function, which is equal to gx. So it means you can just have fx this, then plus gx this. So it will be equal to the first function here. You see, we have our x. By referring to the second property here, we know that the derivative of x will be equal to 1. It means that we have x plus 1 derivative plus x squared plus 3 derivative. So derivative of x is equal to 1. Derivative of 1 here is a constant, it is equal to 0. Then plus derivative of x squared, it means that we have the power which is greater than 1. We can just have the 2x, 2 negative 1, which is equal to 1. Then plus the derivative of 1 is a constant also, which will be equal to 0. So here we remain 2x plus 1. This is the derivative of the fx plus gx. It will be the same as if you have here also the negative. Also, you can just consider your sign, which is negative for each case here. So this is about the derivative of the fourth property, about the addition and the subtraction. So the last property for today is about the if you have your two function, and then you need to make the multiplication. For example, if we have fx then times gx, and as you see, this one it will be long, and I need to introduce about it, and then so for the next time we can just make the derivative of multiplication and even the division. So for the introduction, as we will just continue, and then you can just talk about in full when we just talk about with these two functions of fx and gx here. We see that if you have two functions, you can just have the derivative of fx for the first function, then times our gx, which is non-derivative, then plus because we have the multiplication, and then of fx non-derivative times gx the derivative. It will be the same as for if you have d over dx of fx over gx. So it means that also here it will be the same as in simply the same as for the fx, but there's a little difference. If you have this one, you can just have fx derivative as the first function, then times g x non-derivative negative because we are just making the quotient, and then of fx non-derivative times gx derivative over this denominator function, which is equal to gx squared. So in order to understand very well this property of multiplication and division, we'll just talk about this later in the next video, so as to understand very well. So for today, as I have told you, we have talked about the properties. The first one is as you have the constant, and for the second property is when you have your given linear equation, and this linear equation can be depending on the unknown variable x. And the third property we have talked about if you have a given polynomial function, it means that will be polynomial if you have your n which is greater than 1. And for the another one, which is the last for today, is about if you have the two functions, for example fx and the gx, and those functions which are two, we can just make the addition of those two functions, or you can just make the subtraction of those two functions. So where we have seen that it will be easy if you make the derivative of the first function plus or negative the derivative of the second function. So thank you for today. See you next time.